All right, chapter 4, expressions with rational exponents and radicals. So we're going to talk about rational exponents first. Objective, students will be able to use the properties of rational exponents to simplify and evaluate expressions with rational exponents. Before we do this, we have to think about a little bit of review about exponents. So 2 squared, doesn't that mean 2 times 2, and that's 4, right? That means 2 times 2 times 2, and that's 8, and this means 2 times 2 times 2 times 2, and that is 16. And 2 times 2 times 2 times 2 times another 2, and that is 32. Okay, so since 2 squared is 4, that means 2 is the square root of 4. So if we were to take the square root of 4, right, we would get 2 back. So these are the initial action, and then this is the opposite action, and that's kind of what I want us to focus on here. So 2 cubed is 8. Therefore, 2 is the cube root, or the third root of 8. And 2 to the fourth is 16, so 2 is the fourth root of 16. So all I'm saying here is if I ask for the fourth root of 16, it would be 2. And in the same way, 2 is the fifth root of 32, because 2 to the fifth power equals 32. All right. So some basic kind of just language there, some expressions there to kind of think about what a cube root is or what a fifth root is. Now, let's talk about some of these example problems. Well, first one, just ask for the third root of 8. Or, see, you're used to seeing just something like this, and you know that that's 5 because it's a square root. But there's actually an imaginary 2 here. It's implied. Anytime there's no number there, it's just implied that it's a square root. But now we're going to see things like third roots and fourth roots. And so when they ask for the third root of 8, again, they're saying, hey, what number multiplies by itself 3 times to get 8? And well, we already know it's 2 because we did it above. So this whole thing is just positive 2. Okay, what about the cube root of negative 1,000? Negative 1,000. So again, what number times itself 3 times? Or another way of saying this is maybe x to the third power equals negative 1,000. Well, think about it a little bit. Ignore the negative for a little bit, and just think of the number 1,000. Is there anything that times itself 3 times would give you 1,000? And you might think, well, that's 10, right? Isn't 10 times 10 times 10, doesn't that equal 1,000? It does. Now they're saying that it's negative, though. So what do we do here? Well, what about negative 10? Well, negative 10 times negative 10 is positive 100. But if I'm still multiplying that by negative 10, well, that would be negative 1,000. So, negative 10 is actually the number we're looking for here. The cube root of negative 1,000 is negative 10. So, just an interesting way of thinking about things when we talk about the cube root or the square root. But it's important that we understand what it is that we're thinking about. Okay, for example 3, I want to let you know about something, and we'll talk about this more later, but you can manipulate this so that they're asking for the third root of 1 over the third root of 27. And this may make it just easier to think about. So what times itself 3 times equals 1? Well, that should be easy. That's just 1. But what times itself 3 times equals 27? And this one you should actually know, right? What to the third power is 27? You should have seen this one by now. And it's actually 3. 3 to the third power is 27 because 3 times 3 times 3 is 27, and so you would just put a 3 here. And so the answer to this one is just 1/3. All right. For example 4, I'm going to recommend that you do what I did in example 3, but first, let's make this into a fraction. So let's think about this. Actually, I think this should not be a negative, so let's just make this a positive, just so we can understand we cannot take the square root of negative numbers, so I'm pretty sure that's a typo. So let's think about this. What is 0.01 written as a fraction? Well, 0.01, what you can always do is just kind of like put it over a 1. And you can think about, like, what do you have to multiply by to get that decimal over 2 times? Well, multiplying it by 10 would move it over 1, so let's multiply it by 100 to get it over two spaces. But we can't just multiply the top by 100. That would change its value. But if we multiply by 100 over 100, that's like multiplying it by 1, and so we have, basically that would just be a 1 on top, because 100 times 0.01 is 1. And on the bottom we have 100. So this whole thing is actually like saying, what is the square root of 1 over 100? And converting decimals to fractions is a skill you should be fluent with, but I understand that not all of us are. And now this should be pretty straightforward, because what's the square root of 1? What times itself equals 1? Well, that's just 1. And what times itself equals 100? Well, we already saw this earlier, right? It's 10. And so we would just write 10. Okay, so we've figured that out. And if you wanted to write it back in the decimal form, you could. That's just 0.1. Alright, so that was just some playing with roots and cube roots and square roots and that kind of stuff, just to familiarize yourself with that language. Now, I want us to talk a little bit about some rules of exponents. The first one here is one that you should have already seen before, and that is whenever you have an expression with an exponent raised to another exponent, you can just multiply these. And let's talk about why that is real quick. Let's say I had x squared cubed. Well, doesn't that really mean x squared times x squared times x squared? And so really what I'm saying is I have 3 sets of x squareds. Well, and we should already know that when we're multiplying multiplying expressions with the same base, we can just add the exponents. And that should be pretty clear as to why, because x squared is really just x times x, and this is another x squared, so it's just x times x, and then x times x. And so we could see that really we have 6 x's being multiplied together. And so this whole thing is just x to the 6. So you don't have to write all this out. You could just multiply these exponents. That's the idea here. Well, that's review, but now this is going to allow us to do something else that's kind of important here. This allows you to rewrite rational exponents. So rational exponents, that's when we have a fraction in the exponent as a root and vice versa. So let me show you what I mean. Let's say we had some number to a fractional exponent. Well, since we already know that if you have an exponent to an exponent, that's the same as multiplying. We could do the same thing in reverse. If we already have 2 numbers that are technically being multiplied together, you should see this is actually a divided by b is the same thing as a times 1 over b. That means you kind of separate it like this. And this isn't really useful, but this helps us understand something, that when we have 1 over b, that number on the bottom, well, that's the same thing as the root or the index that we'll have in any type of root. So, and then this a would just kind of go on the outside, and it can actually go on the whole outside or it can go underneath the root symbol. It doesn't make a difference. So let me just give you a quick example of what I mean by this. Let's say I had x to the 2/3. Well, this is pretty simple now. Because of this property, because I can kind of separate these, I can actually just write this as x squared. I'm going to kind of separate out the square. So here's like the x squared. And I got to think about what I do with this number on the bottom. Well, that number goes in the index here. So this is really like saying the 3rd root of x squared. Okay, so this is going to take a little practice to get used to, but it's pretty simple. If you just remember the number in the bottom of an exponent goes in what I call the crack here, in this little space. The other number just goes on the outside. If you do that, can't go wrong. So let's practice this. It just says, example 1, rewrite the expression as a root and then evaluate it. Okay, so let's take a look at this. 32 to the 1/5. Well, first of all, the number on the bottom here, that's what's going to go in the crack, right? So I'm going to put a 5 here and a 32. And this is like saying 32 to the 1. And remember that top exponent can go on the inside or the outside. It doesn't matter. So Well, what is the fifth root of 32? In other words, they're saying what times itself 5 times equals 32. And this is one that we actually saw way up here, right? We saw that 2 to the 5th equals 32. So we actually know how to do this one. This is the fifth root of 32 is actually just 2. Because 2 to the 5th equals 32. So that's how you have to think of these. All right. Let's go on to example B here. So I have 125 to the 2/3 power. Well, remember, the number on the top, that's just, that can go on the inside or the outside, doesn't really matter. And the number on the bottom goes in the crack. So I've rewritten it, and now I want to evaluate it. So what is the third root of 125? I'm going to do this part first. I'll do the square math. So what times itself 3 times equals 125? Now I will let you know this is actually something your calculator is capable of doing. You may want to just kind of Google your model of calculator and see how to do it. But it's very easy to plug this into a calculator. But you should be able to see pretty quickly that a number to the third power that equals 125, well, that's actually 5. Right? Because 5 times 5 is 25, times another 5 is 125. So this is the same thing as saying 5 in those parentheses squared. Well, 5 squared is 25. Boom. Hopefully we're getting a little bit of some sense for how this works. Try C on your own. It's 81 to the 1/4 power. So first rewrite it as a root, and then evaluate it. Give it a try and then unpause when you're ready to check your work. Okay, well, the 4 is what's going to go in the crack. The 81 goes inside. 81 to the 1 is the same thing as 81. So we're really just saying we're the fourth root of 81. So what times itself 4 times equals 81? Well, that's 3. I already am familiar with this number because 3 times 3 is 9, and 3 times 3 is 9. And 9 times 9 equals 81. So that works. The answer to this would just be 3. Let's go to the next page. All right, this brings us to another rule that I want us to consider, and that is what a negative exponent does. A negative exponent just tells us to take the reciprocal of that value. So that just means if it's on the top, you put it on the bottom. If it's on the bottom, you put it on the top. That's all it means. So a negative exponent is going to make it go on the bottom. And so we're going to rewrite these ones as though it's just x to an exponent. Okay, well, let's think about this. There's x to the 4th here, but it's on the bottom. So to make it go back on top, I would just have to make that exponent a negative 4. And this 1 is really still here. It doesn't really matter, but it's still there. But I just don't have to write it. Okay, let's do part B. Well, B says, or part B says it's 1 over b to the negative 7th. Well, it's already on the bottom and it's negative. So let's just think about that. Let's do this. Let's say I wanted to just put the whole parentheses on the top. Well, wouldn't that just be b to the negative 7th to a negative 1? Right? I could do it that way if you want to think of it that way. Well, remember, if I have an expression with an exponent raised to another exponent, it's like multiplying. So this is like saying b to the negative 7th times negative 1. Well, negative times negative is positive, so this becomes b to the 7th. So we could see this that just by changing this to a positive, we're allowed to bring it up on the top. And again, there's an imaginary 1 here the whole time. We don't need to write it. So if there's just a 1 on top, you don't really have to write it. Maybe there could be a 2 here, and you would just put a 2 there. That's all. Okay, I want you to try part C on your own. And once again, pause the video, and then come back and check it when you're done. Yeah, you would just change that exponent to a negative, and that would bring it back up to the top. So remember, it's important. It's not so much that the negative makes it go on the bottom. It's just that the negative makes it do the reciprocal. So if we want the reciprocal of this, we would make it a negative exponent. Okay. We've learned a lot of properties of exponents now, especially rational ones. And so let's try and put it together with these last 2 questions. First one, example 3 says, which of the following radical expressions is equal to a to the 1 over 37? So let's think about this. What does this fraction mean? Well, remember, it means that the a is going to be the number inside the radical, and that 1, that could go on the outside or the inside, and the 37 is what's going to go in the crack. So now I just need to look and see if any of these are the same. And the first two I see right away, these can't be it, because notice they're moving the 37 to be the number in the inside, and the a is the number in the crack. But remember, that can't be it. The a is the number that we're addressing. The 137th is just the exponent. And so remember, these numbers come from the denominator of the exponent. So this cannot be it. And then here we see that the a is on the inside with 37 in the crack. So these look reasonable. But there is no negative exponent here. There's nothing to change it into a 1 over a. So this is not it. And part C looks a lot like what we have. So there we go. Okay. Summary, it says, explain in your own words what a negative exponent means and what a fractional exponent means. So you've gone over that. I want you to explain that back to me in your own words. And that'll be it. See you guys on the next video.